So this is a walkthrough of the review for the confidence interval quiz for Unit H. So for partner A, you screen 200 male students for color blindness and you find that 15 are colorblind. Check the conditions to estimate the confidence interval. Now, first of all, when you look at your unit packet, which I'm going to go ahead and open one of them, H packet, there we go. If you look at the very beginning on the inside, it has the conditions right here. So if you're doing a proportion, we have the confidence interval here. You got random sample 10%, that the sample is less than 1/10 of the population, and you have the normal and large counts condition. So remember, on your quizzes, you are allowed to use your packet. You're also allowed to use it on retesting, provided you complete the packet. And so this is a good resource right here. Okay. So we have the random condition, and you can see that here, random 10% and large counts. So our random condition, well, we have to assume the students were randomly selected. I didn't say they were randomly selected, or you can assume they were representative. Either one of those would work. In fact, I'm going to add that in, randomly selected or representative. The goal is actually representative. Randomly selected is one way to get that goal. Okay, so I'm putting that in for both. 10%. So our sample size is 200, and we need that to be no more than 10% of our population. So since we don't have the population, we have to assume at least 2,000 male students in the population. Here we have 80 in our sample, so we have to assume at least 800 adults in the population. Large counts, here's our N, our P, and so we just have to calculate expected number of successes, which is N times P. And then for failures, I could do N times 1 minus P, or I could just subtract the successes from the total. So I've got 15 here and 185. Both are at least 10, so all conditions are met. Over here, when we multiply it out, we have 50, and then we have the remainder is 30. Both of those are at least 10, so all our conditions are met. Okay. Now we find a 90% confidence interval for the true proportion of students who are colorblind. So what I'm going to do is I'm going to go ahead and pull in my calculator, because you can basically just run this through the calculator and give it a second to warm up. I'll pull it over here and try and size it appropriately. That should work. Doesn't really change much there, does it? Okay, so what I'm going to do is I'm going to hit, let me just go ahead and clear this, just so you don't get distracted by anything. And before I use my calculator, I need to know there are 15 out of 200 are colorblind. So I'm going to hit stat test. Even though it's not a test, it's an interval, and it's usually on the bottom. So it's a 1 proportion Z interval. All right, hit enter. And we said 15 out of 200. So if it's looking something like this, and then we can say, okay, what confidence level did we want? We wanted 90. So all I have to do is change this to 0.9, calculate, and there you go, 0.04437 to 0.10563, which pretty much matches our interval right here. So this is kind of rounded. And then, of course, you should be able to interpret it. I didn't say interpret. I probably should have said it. Expect to do that on the quiz. So we are 90% confident that the true proportion of males who are colorblind is in the interval 0.044 to 0.106. All right, let's go ahead and do the interval. And we have 50 out of 80 have diabetes. So we'll hit stat, test. We want a 1 proportion Z interval. That's what we want. And we said 50 out of 80. And this time I think we want a 95% confidence interval. Let me double check. Yes, 95%. And then hit calculate. You can see it's 0.519 to 0.731, which matches what we have here. So again, there was a 95% confidence that I was looking for. So that's how I put in the 0.95. And then there are two values. We're 95% confident that the true proportion of adults who have diabetes is in this interval. All right. Explain what 90% confidence level means in this context. So if we were to repeat this procedure many, many times, so this is sort of boilerplate, we would expect 90% of our intervals to capture the true proportion of colorblind males. For this one over here, we would expect 95% of our intervals to capture the true proportion of people with diabetes. So just change the context, make sure that this number matches whatever confidence level you're looking at, and you should be fine. And if you were to look at your notes, pretty sure this is near the beginning in the confidence interval basics. This one is interpreting the interval, and then this one is if you were to use a blank percent confidence interval, often about blank percent of your intervals will capture the true parameter value. So that would give you, and it's nice to put the context in there. Okay, back to this. According to an AMA study, about 6% of males are colorblind. Does the 6% figure seem reasonable based on your sample? So our sample had an interval of about 4.4% to 10.6%. Since 6% is in the interval, it's reasonable, it's plausible. Over here, we have a study about 40% of American adults have diabetes. Does that seem reasonable? Well, actually, it doesn't because it's not in the interval. Our interval is from 51.9% to 73.1%. So 40% seems too low. It's below our interval. Okay, now for number 5, the fun one, calculating sample size. Now, I did go over sample size in the H2 notes. You're probably not going to have to do it with a 2 sample proportion, but you might have to do it with a 1 proportion sample. So there are a couple things. Here we talk about standard error, and here confidence interval, and then we start calculating sample sizes. All right. So a couple things to keep in mind. All right. If you're trying to calculate sample sizes, you can basically use this formula. And if you don't have an initial proportion, you're going to use 0.5. I thought it was in these notes. Maybe. Confidence intervals should have been in these notes. Maybe it was in my other notes. But the worst case, here it is, right here, where we calculate sample size. All right, so the very end of the H2 notes, you have some nice examples right here. If you don't know the initial proportion, use 0.5. All right, here we don't know the initial proportion, okay, because we're looking at teenage Americans. Up here we were looking at adult Americans. Here we are looking at female students, and before we were looking at male students, okay? So we don't have an initial value, so we're going to use P equals 0.5. So what I wrote down is the margin of error, the confidence level, and then I calculated the critical value. Remember, you can just basically do that by, let me pull this over a little bit so we can see the numbers, how to calculate it. So if you want to calculate a critical value, you go second distribution, inverse norm, all right, at least for proportions, and we want 99%. So if you have one of the newer calculators, you can just put that 99% in and make sure you hit center because we want it in the middle, and then hit paste. And there you go. There's your critical value, 2.576. All right, and then for the other one, it's a 90%. So I can just do the same thing. Second distribution, inverse norm. Change that 99 to 90. Make sure it stays in the center. And then go down and paste. And we get a critical value about 1.645. Okay, so that's how you calculate it. And there's the shortcut right here. And right here on how to plug it into your calculator. All right, you put your area in, use a mean of 0, a standard deviation of 1, because we're doing a standardized critical value, and you want center area. Now, we're going to use the formula that margin of error equals your critical value times your standard error. So here it is, kind of plugged in a little bit more. And now we put in some numbers. But since we don't know p hat up here, we're going to assume it's 0.05. That's the worst case scenario that I just showed you in the notes. And you can square both sides and you can solve for n. One strange thing is you always round up. Even if this was 1036.0, you would still go to 1037. Same thing on this side. We put in our critical values. We can square both sides. And we have 751.67. Always round up. Even if that was 0.4, it would still go up. And your answer is 752. So, again, now there is a shortcut in these notes right about there. So that shortcut will actually give you the sample size. It'll work fine for your test. You won't have that for the AP exam, but since you're allowed cheat cards in my room, for right now, if you're weak on the algebra, you can go ahead and try and memorize this, and that should save you some time. So that's optional for your cheat card.